Reflection means bouncing off. Let's study the reflection of light. Remember, we've already discussed that opaque objects do not let light through them. They are also not luminous. They do not shine. The reason why we can see an opaque object is because when light shines on it, some of that light is absorbed and some of that light is reflected. It bounces off the object. And that reflected light could come to our eyes, and then we can see the object according to what colors reach our eyes. So we can see that reflection is very important for letting us see things. If there was no reflection, we would not be able to see any objects except those that are luminous. We would not be able to see one another because we are not luminous, and most of the things around us are not luminous, so we would not be able to see very much. So reflection is very important to us. So let's study it. Let's imagine we have a mirror or any other smooth surface. Here we have a luminous object, a shining object, like a light bulb. That luminous object gives off light. The light travels all around. We're going to look at one ray of light here. This ray of light comes to the mirror. We call it incident light. Incident means it's coming to. So in this case, it's coming to the mirror. The mirror bounces that light off it. It reflects that light. And if our eye is in the right place, we will then see that light bulb in the mirror. It doesn't have to be a light bulb. It could be another object which is reflecting light off it to the mirror. The word reflect means to bounce off. Before we can study reflection, we need some words to help us. I've already spoken about incident light, meaning the light that comes to the surface, and reflected light, meaning the light that goes away from the surface. But here is another word that can help us to understand reflection. Normal. The word normal in science means at right angles at 90 degrees. A normal line is an imaginary line, meaning it's not really there. We just draw it in. We imagine it. That we draw at 90 degrees to a surface, perpendicular to a surface. So you can see here we have the mirror, and at the point where the incident light meets the mirror, we draw in a normal line. Even though it's not really there, we imagine it to be there, and we must make sure that that normal line is at 90 degrees to the mirror. Next, we measure the angle between the normal line and the incident light, and we call this angle of incidence. And we measure the angle between the normal line and the reflected light, and we call that angle of reflection. So now we're ready to play around a little bit with our simulation. So we open the bending light simulation. Now you can see in the simulation when we put the light on, light is shone through some air into, in this case, some water. And as it travels into the water, it bends. But we are not going to focus on that part. Let us just look at the air part of the simulation and ignore this bottom part. And can you see that some of the light, when it strikes the boundary between the air and the water, it is reflected, it is bounced back into the air. And that is what we're going to focus on in this movie. So here we have the incident ray, or the incident light, and this boundary here is acting like a mirror. And here we have the reflected light that is bounced back. You can see that we can show the normal line, and you can see that we can alter, we can change how we shine our incident light. We can make the angle of incidence smaller or greater. So how can we turn this into an investigation? What question can we ask to investigate reflection? We want to ask a question in this form. How does the independent variable affect the dependent variable? Now, what can be our independent variable and what can be our dependent variable? Independent variable means the variable that you as the investigator change. So what are we going to change as we move this light source around? That must go on this line. And then, because of that, something else will also change. That will be our dependent variable. What must go on this line? Try yourself. Did you come up with this? How does angle of incidence affect affect angle of reflection. We are going to change the angle of incidence. We're going to move this light source in such a way that it makes the light shine more directly or less directly. In other words, have a small angle of incidence or a big angle of incidence. So that is our independent variable. And as we do that, that will affect the angle of reflection. How will it affect it? So before we collect our data, let's prepare a table so that we can put our data into it. Our question is, how does angle of incidence affect angle of reflection? Angle of incidence is our independent variable. That's the one we are going to change. That is the cause. Where must that go in our headings? Angle of reflection is our dependent variable. It's our outcome. It's the effect. Where must it go in these headings? Pause the movie while you complete the gaps here. Table showing the relationship between angle of incidence and angle of reflection. Angle of incidence is our independent variable. It comes in the first column. Its unit is degrees. Angle of reflection is our dependent variable. It comes in the second column and its unit is also degrees. Now we need to decide on some angles of incidence that we're going to use. We can really use whatever we like. How about these numbers? 10, 20, 30, 40, 50. And we could even have more. And what we need to do now is open our simulation and measure the angle of reflection for each of these angles of incidence. So we open our simulation, we put the light on, we put our normal line in, and then we also bring in a protractor so that we can measure our angles of incidence and reflection. So the angle on this side is the angle of incidence, and the angle on that side, angle of reflection. So we make our angle of incidence 10 degrees. And now we measure what is our angle of reflection, also 10 degrees. Now we increase our angle of incidence to 20 degrees. We go to the right-hand side, we look at our angle of reflection. It's also 20 degrees. Increase angle of incidence to 30 degrees. Angle of reflection, also 30 degrees. Angle of incidence, 40 degrees. Angle of reflection, also 40 degrees. Increase the angle of incidence to 50 degrees. Angle of reflection, also 50 degrees. And we could continue. 60 degrees angle of incidence, 60 degrees angle of reflection, 70 degrees angle of incidence, 70 degrees angle of reflection, 80 degrees angle of incidence, and 80 degrees angle of reflection. So what do you see? How does angle of incidence affect angle of reflection? Angle of reflection equals angle of incidence. Whatever the angle of incidence is, the angle of reflection will be that same number. And that is called the law of reflection. Always, the angle of incidence equals the angle of reflection. Now, this is true even if you have a rough surface. But with a rough surface, it's not so easy to see this because at each point, the angle of incidence is equal to the angle of reflection. But because the surface is rough, those angles of reflection are different from different places. And so the light gets scattered. And that's why you can't see your face in a rough surface, whereas you can see your face reflected off a smooth surface. That's why a mirror, of course, must be very smooth, so that it reflects the light nicely all in one direction and you see a nice clear image. So reflection means bouncing off. The light that comes to a surface is called the incident light. The angle between it and the normal line is called the angle of incidence. The light that gets bounced off a surface is called reflected light. And the angle between it and the normal is the angle of reflection. Remember, the normal line is an imaginary line that we draw at right angles to the surface. And always, the angle of incidence equals the angle of reflection, and that is true whether the surface is smooth or rough, but the point is that when it's smooth, this happens in such a way that you can see a nice clear image, whereas for a rough surface, the light gets scattered, and so you don't see a nice clear image.